Welcome back. In this video, we are going to solve a structural design problem that involves a simple beam design using load and resistance factor design method based on eStructural Design Tao found on the App Store. Design a reinforced concrete beam using load and resistance factor design with simply supported span of 30 feet, assumed size of 16 inches by 32 inches. The beam carries a uniform dead load of 1,400 pounds per foot and uniform live load of 3,500 pounds per foot. Design criteria as follows. Strength of concrete 7,000 psi, main bars 1 inch diameter grade 60, stirrup bars ½ inch diameter grade 60. The beam carries a uniform dead load of 1,400 pounds per foot and uniform live load of 3,500 pounds per foot. The beam self-weight is 534 pounds per foot for a total factored load of 7,920.8 pounds per foot. Enumerate input parameters required. Name of beam B13, type of support simply supported, width of beam 16 inches, depth of beam 32 inches, length of beam 30 feet, main bars 1 inch diameter at grade 60, stirrup bars ½ inch diameter at grade 60, strength of concrete 7,000 psi, and total load 7,920.8 pounds per foot. Given factored load equals 7,920.8 pounds per foot, L equals 30 feet, the maximum moment is 10,693,080 inch-pounds. The raw max from the given design criteria is 0.03081. Then the maximum concrete beam design ratio Rn max equals 1,560.57 psi, followed by maximum moment from given section Mu max equals 19,556,439.01 inch-pounds, which is greater than the maximum design moment Mu. Given maximum moment equals 10,693,080 inch-pounds, resistance factor equals 0.9, B equals 16 inches, and D equals 29.5 inches. The beam design ratio Rn equals 853.29 psi, and reinforcement ratio Rho equals 0.01542. Given Rho equals 0.01542, B equals 16 inches, and D equals 29.5 inches, the area of steel for tension bars is 7.27824 square inches, and the number of bars for 1 inch diameter is 10. The number of compression bars is 2. The shear force for dead load is 29,010 pounds, and live load is 52,500 pounds, for a maximum shear force of 118,812 pounds. The nominal shear force is 158,416 pounds, greater than 78,980.71 pounds concrete capacity. The shear force capacity of stirrup is 79,435.29 pounds, less than 315,922.83 pounds. Maximum stirrup capacity. Maximum spacing is 10 inches. The shear force at face of support is 59,576.47 pounds, and initial spacing at 11.88 inches. The stirrup spacing are as follows: 1 at 2 inches, 1 at 4 inches, 1 at 6 inches, rest at 10 inches. For 1 inch diameter main bars, use ½ inch diameter stiffener bars. Design recommendation as follows. Fc prime equals 7,000 psi, Fy equals 60,000 psi. Beam size is 16 inches by 32 inches by 30 feet. Main bars of grade 60. At support, top bars 10 pieces 1 inch diameter bar. Stiffener bars 2 pieces ½ inch diameter bar. Bottom bars 2 pieces 1 inch diameter bar. At center, top bars 2 pieces 1 inch diameter bar. Stiffener bars 2 pieces half-inch diameter bar, bottom bars 10 pieces 1-inch diameter bar, stirrup of 2 legs of grade 60, half-inch diameter bar spacing, 1 at 2 inches, 1 at 4 inches, 1 at 6 inches, rest at 10 inches. Thank you for watching. If you learned something from this video, please like, share, and subscribe to this channel.